All right, so today we're going to look at numbers 8, 9, and 10 from the 9-3 worksheet. So we'll start with number 8. And so we're picking up with identifying the limiting reactant. Remember, when we identify the limiting reactant, we have to have a balanced chemical equation. So we're looking at CaCl2 is reacting with Na2, CO3, and it's going to produce CaCO3 and NaCl. And so we want to have our BCA table. In order to do that, it needs to be balanced, which it's not. So 2 chlorine, we'll put a 2 here to get 2 chlorine. That gives me 2 sodium, and we're balanced. So remember, you have 0 of your product before you start. Minus x, plus x, plus 2x. And then from here we can convert the grams that were given in the problem. 65.14 grams of CaCl2. And we can go 74.68 grams of Na2CO3. And we'll find the molar mass of both of those. .89. And 105.99. Now we can convert to moles. And so we can take those number of moles and put them in our table. And from here, find the limiting reactant. Well, the change is the same. So then we look at the smaller number. You're going to run out with that first. Remember to double check. We can solve for x. 0.694 minus x equals 0. X equals 0.694. And so from here, we can plug in our x here to see if we get a positive number. And we see that we do. And so we know that because you run out of CaCl2 first, your limiting reactant is CaCl2. And that's number 8. We can move on to number 9. Again, identify limiting reactant. We need balanced chemical reaction. So you're having SF4 is reacting with I2O5 to produce IF5 plus SO2. And so now we gotta balance this. Sulfur's good. Fluorine, there's 4 here, but there's 5 here, so we're looking at least a multiple of 20. So to get 20, we're gonna put a 4 here and a 5 here. And so when we look at I, we have 4 here. And so then we need to get 4 here, so we're gonna put a 2. That gives us 4 and 4, which is good. Oxygen, that gives us 10. So we need 10, we put a 5 here. That gives us 10 oxygen, 5 sulfur, and 5 sulfur, which is what we wanted. So there's your balanced chemical reaction. A little bit different than ones we've looked at previously, but again, balancing, we're just counting. And so you have 0 of your product before you start. Minus 5x, minus 2x, plus 4x, plus 5x. Again, the 5's coming from there. 2 from the coefficient, 4 coefficient, 5 coefficient. Now take the grams we're given in the problem and convert. 4.687 grams of SF4. And 6.281 grams of I2O5. 0.05. We look at SF4. Let's see. So we can convert those to moles. So SF4, we're going 0.0434 and 0.0188. And so we can see here a little bit different. So this is, we have more of this and less of this, but this is going away 5 times at the rate of 5 versus the rate of 2. And so what we can do here, it's kind of a little trickier to figure out, so we can just guess. And so I'll kind of show you with just guessing. So let's just pick one. Pick this to go to 0. 0.0434 minus 5x equals 0. Well, we can just go ahead and solve for x. And I'm getting 0.00868. So let's plug that in here and see what we get. Again, if we get a positive number here, we're good. But if it's negative, we pick the wrong one to go to 0. So 0.0188 minus 2 times 0.00868, I'm getting 0.00144. And so because it's a positive number, we picked the right one to go to 0, and so we know our limiting reactant would be SF4. All right, now moving on to number 10. Number 10 is slightly different. Slightly different in it's asking a little bit different question, but we're gonna solve it the same exact way. And we're just gonna have to go one step further. And so instead of saying what's the limiting reactant, it's asking for a mass of product that will be produced. But you'll notice you're still given 2 numbers, 4.1 grams of CR and 9.3 grams of Cl2. Because we're given 2 numbers or 2 masses to start with, we have to do a limiting reactant setup. We have to figure out which one of those runs out first. And so we still write our balanced chemical reaction. CR is heated with Cl2, and it's gonna give us Cl3. We'll set up our table. We have to balance, so you notice 2 and 3, so the least common multiple is 6. So I'll put a 2 here, a 3 here, and then to get 2, we'll put a 2 here. So then you have 0 of your product before you start, minus 2x, minus 3x, plus 2x. So the only difference here is we gotta fill in this side, but we're also gonna have to fill in this side as well and get this number because again, they're asking us for a mass, which is grams of CrCl3. Same thing here, we have to take, because the only numbers you can plug into this table are moles, so we have to take the grams that they give us, 4.1 grams of Cr, and we have to convert that. And so we can see, we can take the mass here, chromium, let's say 51.99. Again, you may be rounding it slightly different, which is okay. 9.3 grams of Cl2. So we're getting in 1 mole, it equals 70.9 grams. So let's convert. 0.0789 0.131. So 0.0789 0.131. And so that's a lot smaller. Let's just pick that to go to 0. 0.0789 minus 2x equals 0. X equals 0.03945. Let's plug that in and see what we get. .01265. We get a positive number, so that means we picked the right one to go to 0, but the question is asking about CrCl3, so we've got to find this number here. So we want to now take X and plug it in, which again, that's different from what we've been doing because they're not asking for limiting reactant, they're asking for a mass of a product. But in order to do that, we've got to figure out which one of these runs out first. And so this is 0.0789 moles of CrCl3. Now the question asks for grams. Mass is grams, so we got to convert this. So I'll just do that down here so we have space. Moles of CrCl3, and you can convert that to grams. In 1 mole, there's a certain number of grams. Get 158.34. So we know that we should get 12.49 grams of CrCl3. So the only thing different here is we do the limiting reactant like we've been doing in previous days, but now we have to fill in the after for our product. And then from here, because it asks for mass, we have to do one more step in converting the moles into grams, but you already know how to do that. So, and that's what we'll do in the later questions now tomorrow, and this one today, where they're asking for a mass of a product, remember mass is in grams.